Now, the mechanism of reducing an aldehyde to a ketone, exact same mechanism can be applied to a ketone to a secondary alcohol, so don't need to worry about learning two different mechanisms, but you should probably practice with a ketone. So, a couple of key things before we start the mechanism, before I shall go through the mechanism. The H- ions come from the reducing agent NaBH4, sodium borohydride, pretty sure it's called, but you just need to know NaBH4. Knowing the name is obviously a good thing as well, in case in the exam they don't use this, they use the name. And now what happens is the aldehyde, RC1OH, now the lone pair of electrons on the hydrogen, which is negative, we don't use the whole thing, NBH4, BH4, we only use one hydrogen, which is negative lone pair of electrons, attacks a partially positive carbon, which now breaks the CO double bond. Now you can see here, perfectly fine. Now the oxygen has a lone pair of electrons negative charge, perfectly fine, but now what happens is the oxygen is now going to bond to a H+, attract to a H+, and now what happens is the R, in this case H3C, CHHOH. So this is called nucleophilic addition. So this is what happens with nucleophilic substitution. And then we're adding this H+, so nucleophilic addition. So we know the H- ions, when we're reducing aldehyde to an alcohol, to primary alcohol, or an alcohol, the H- ions come from reducing agent NaBH4. The H+ ions come from a water or a weak acid. This whole thing is called nucleophilic addition, and the H- ions basically act as a nucleophile and add on to the delta partially positive carbon atom.